Thanks a lot for hanging out till the end of the day and almost the end of the talks of this session. We've seen a lot of really cool work throughout the day. So I'm going to quickly talk you through some of the projects and efforts that me and my lab have been engaging with on thinking about how does working in large groups of people through computational interfaces and computational media help us think about designing things together at the scale of the city within the urban planning and urban design sort of field. So drawing participation is an open source software tool that me and my students have developed together that enables essentially to synthesize two different types of software typologies, spatial analysis and computer-assisted design. It allows users to draw, sketch, and co-design collectively in a single web platform. So within the field of planning and design, especially in a public-facing domain, whenever there's a public-facing project, local governments are for the most part able to do community planning workshops where they present the project that is meant to be deployed or solicited within a local context. But oftentimes, this community planning workshops or community design workshops are limited to an in-person modality where a limited number of people can actually participate. And oftentimes, what is shown in these workshops is what the final design is going to be, and the people that attend can give comments and so on and so forth. So they oftentimes don't have a final say on what the output will be or what the process of designing that output might be. These workshops are also pretty much divorced from the process of making them, so they're disconnected from the tools that designers, planners, or architects follow through to make them. In some cases, this planning workshops or urban design workshops do have some technological facilitation, but in this case, the input that community residents have is oftentimes just tweaking sliders through a simulation of different scenarios that have been pre-computed for them. So with drawing participation, what we aim to do was integrate drawing, data collection, simulation, and spatial analysis, bridging CAD, GIS, and community participation within an intuitive and visually based platform that is available openly and freely online. So with the tool that we developed a number of years ago, a diverse number of users can draw together in a shared information model that ultimately acts as a communal blackboard. Designers in some workshops that we have ran in the past have used this tool to collectively assess or comment on a current proposal and discuss whether or not proposals are required by the community. Or in this video of a workshop that I ran with some past students at MIT, users were able to collectively build a personal map of their neighborhoods. Specifically in the context of contentious future scenarios, with the tool we incorporate real-time simulation of ecological conditions or environmental modeling, which gives real-time feedback to the users of the input and changes that they're making. So in this workshop, users were engaging with a sea level rise modeling and simulation platform, where they decided whether or not they wanted to build levees around MIT and which areas they wanted to save versus which areas they wanted to enable the sea level to rise again. Other students with arts backgrounds had adopted the interface as a way to create public art exercises as well. But what I am going to present now is the efforts that me and my students have engaged with on extending this platform towards a broader project where we are working with colleagues at the University of Chicago in the process of mapping and mapping cadastral or creating cadastral maps across informal settlements. So currently, over 1 billion people live in informal settlements, and among a number of the issues that these communities face is a lack of land tenure, which ultimately is a barrier for local governments to provide essential services like water, sanitation, access to emergency services, street access, et cetera. And the process of creating land tenure maps or cadastral maps is oftentimes divorced from any type of community input. So in collaboration with our research partners, we have developed machine learning approaches and remote sensing approaches that have helped us produce a large-scale data set that has mapped and characterized thousands of informal neighborhoods across the world. So with this processor framework that we have created, we've been able to quantitatively characterize these underserved communities, essentially describing them by whether or not, or how many degrees of separation they have to existing street networks. So the further away a community is, or the lack of access that a community has to existing street networks, the higher the degree of informality it's going to have. So in a very early version of this work that we did a number of years ago, we tackled the problem of both creating these cadastral maps and creating a new map of how these neighborhoods might look like if you were to introduce a street network and essential services to the community. We created a constraint optimization algorithm that essentially tried to connect every single parcel that we identified with a street access. But obviously, what existed in the aerial maps that we created was very much different from what's on the ground. And our constraint optimization algorithm essentially tried to reduce the number of parcels or houses that would be demolished if you were to introduce a new street network, which ultimately doesn't work out because people live in these places, they have personal interests, and there are competing interests, and ultimately is fully divorced from community input. So in our previous approach, our approach was suboptimal because there are a lot of stakeholders and personal interests that are involved in this process. So what we did was extend this earlier efforts of characterizing the informal settlements and couple that with our community-based participatory design platform. So as part of the process, we also have ever since developed generative AI algorithms that help us provide a baseline model of what a cadastral map might be for each one of these communities. And then we use the platforms that we have developed for community members to co-design their cadastral maps to modify and tell us what the actual right configuration of these maps should be. So I'm going to quickly go through the next set of slides in the interest of time, but essentially our generative AI algorithm takes aerial images of these communities and infers, or we have trained our models on image pairs of multiple cities throughout the world that show both existing buildings and existing parcels. To be able to infer what a baseline parcel might be. So based on this baseline models of buildings and parcels throughout the world, we can synthesize a baseline parcel that the users then can modify with our platforms. All of this code is available online on GitHub. It's openly available also on Hugging Face for people to use the trained models that we have developed, and we're in the process of documenting the whole pipeline that we have created. And this is useful not only in the context of informal settlements, but for local governments that don't have access to cadastral maps. Locally, they can produce an approximation of what a cadastre might look like as well. So anyhow, we have developed this web-based multi-user tool, and we are in the process of migrating this baseline cadastral models into each of the communities that we have identified. And in partnership with Slum Dwellers International, which is an NGO based out of South Africa, we are in the process of also running community workshops where we introduce a platform to sort of like test out how the process of creating cadastral maps and reblocking proposals might look like if it were to be done at scale through the use of our platform. So in one of such workshops, as a number of residents were able to take these baseline cadastral maps and modify them. Obviously, there were disagreements between neighbors of what the property limits is, and across many different communities that we work with, the concept of land tenure is quite different. So that's a challenge that we are facing and that we're going to have to continue integrating. But as part of this process of collecting multiple opinions and multiple visions of what a local cadastre might be, we also realized that we had to design a way to help us keep track of what multiple residents were proposing. So we developed a version control system that is spatially aware, and through the version control system, we can keep track, and our NGO partners can keep track of what each resident is proposing. And ultimately, we are also developing models that help us synthesize and interpolate all these resident-led proposals while keeping the topological contiguity, which is something that would be very difficult to do with traditional computer graphics approaches. So I'm going to quickly go through this. This is some of the team that has worked with. We've received support from partners and other institutions that have worked with us previously. And all the work that we have done, well, there is an outdated repository of the work that we've done, and we're in the process of migrating both the models and the platform into the web page out there. So if you guys have any questions or want to follow up, feel free to reach out to my email or find me at the end of the talks. Thank you very much. Oh, and I guess we have time for questions.
Hey, thank you. I was just curious, like, in using the tool to have like community members go in and make some of their own edits and proposals, like how you found, like, did you have a workshop where you'd kind of explain how to use the tool, or did you just purposely make the tool super user-friendly, or do you have kind of some help tips, or just kind of, I wonder about that process of like taking people that maybe aren't necessarily super tech savvy, but then having them understand how to kind of edit some GIS data almost.
Yeah, no, that's a great question, and thanks for the question. It's been a little bit of both, and it's been a process. The initial prototype of the tool was created throughout part of my PhD, and it was mostly divorced from community input. But through the process of working with our NGO partners, we have sort of like adopted a participatory design process for the software that we're developing. So the initial intention was to make the tool super visual, so that people could use it right away. But obviously, there's a lot of knowledge baked into cartographic tools that community members don't necessarily engage with in the same ways that an audience like this would. So we have found that also the people that are running or helping us run the workshops and the workshop facilitators have a central role on how do the tools get used, and as one of the examples that I showed where I ran a workshop with mostly art students, they misappropriated what I thought the tool was for, and then they just start to make drawings of like animals around New York City. So there's a little bit of both. There's what the tool was meant to do, the role that facilitators have in the process of running these workshops and engaging with residents, and also the end users misusing and reinventing how the tool gets used. So ultimately, all of this feedback gets put into the software development, and it's part of our learning process so far.
One more? Hang on one second. Sorry.
Thanks. I was wondering if you could go into a little more detail about the ML algorithm that's used to kind of reconcile those disputed like property boundaries or territories. Yeah, I was just curious about that.
Yeah. So we have a different architecture so far that we have tried out, and we're in the process of deploying new architectures for the models. But ultimately, what we do is we have trained a couple of different architectures. We have autoencoders, which essentially are pre-trained on a large set of cadastral map data sets, like thousands of cadastral map data sets throughout many diverse cities in the world. And we have also different type of model, but they're all similar. So we train the models with thousands of cadastral map images, and then once we have a number of competing proposals that users or residents create, they'll get sent into the autoencoder model. The autoencoder model changes the dimensionality and reprojects it into a different type of dimensional space. And then once it's in that different dimensional space, we can sample throughout the different dimensions of the model and interpolate between them. So what you're seeing in this image that is sort of like merging or interpolating between many different versions of the model is just snapshots of that different dimensional space in the autoencoder, and we have a different architecture that looks at a different model, but they all sort of like work in a similar way.
And then as a
You have to go. Oh, sorry. We need to move on to our last speaker.
Okay, we can follow up.